In this video, we're going to build an object detection app using free open source AI models hosted on Hugging Face, which is a platform for sharing, training, building, and hosting open source AI models. We're going to dive into Hugging Face and what it is in a second, but let me show you what we're going to build together. So up top, we have this drag and drop area where you can either click to add a file or drag an image file into this, which then it's going to kick off this object detection model behind the scene, which is running inside the browser using something called transformers from Hugging Face. We're going to see what they are. But even though this is a NextJs application, it doesn't have any server-side code. So this AI model is running inside the browser using the transformer.js, and it's actually running on a service worker or on a web worker. So it doesn't block the main thread of the application. It runs behind the scene. Even when we are loading this model, we're using a service worker or a web worker to load this model, because oftentimes these models can be a bit big, and the first time that you run them, it is going to take some time. But once you run them once inside the browser, it's going to then be cached, and for any subsequent images, it's going to use the cached version of the model with these transformers to then do whatever analysis or whatever transformation or inference you were trying to get out of this model. Now I'm going to walk you through every step of this process, but before we get into the code, let's talk about Hugging Face and what it is. As I mentioned, it's a platform for hosting, building, and training open source AI models. Think of it as a GitHub, but for large language models. And unlike OpenAI that have closed source models, these models that you can find here are open source. You have access to the code and you can actually see what goes behind the scene, and you don't have to pay to use them. And Hugging Face also provides some libraries such as its transformers, which is a Python library, and the transformers.js, which is a wrapper or a JavaScript library, basically doing the same thing, which helps you create these pipelines that allows you to create inferences from inputs and outputs. It also does have a Hugging Face.js, which is again a collection of libraries that allows you to talk to different API endpoints inside of Hugging Face and different models that are provided here. So definitely check it out to have a better understanding of what it is. I'm on /docs inside Hugging Face, and here you can just go to different libraries, different APIs that are provided from Hugging Face. So today we're going to use the transformers.js. This is similar to the Transformers Python library that is going to allow you to use pre-trained models in a similar way that you would use in Python, but inside of JavaScript. Now you can run transformers in server-side in Node.js, or you can run them in the browser, and this is what we're going to do today. Now the main API in the Transformers library is the pipeline API. Pipelines group together a pre-trained model with pre-processing of inputs and post-processing of outputs, making it the easiest way to run models with the library. So pipelines basically help you generate inferences from inputs using these AI models. An inference is generating a prediction or transforming your input to an output using these AI models. And pipeline is a way that you can specify the model that you want to use and pass in different options to it, and basically move this input or transform it or create or generate an inference from this input through that pipeline to get your output. As you can see here in the example, we have this pipeline in from the transformers library, and this on the left hand side is where you would use it in Python. They accomplish the same thing. We are getting the pipeline out of the library. We are creating a specific pipeline for sentiment analysis. This is in the text classification category of different models. I'm going to show you where you can find different models hosted on Hugging Face in a second, but you would define the ID of the type of model that you want to run. And if you don't pass the specific model that you want to use, Hugging Face is just going to use the best known or the most popular model for this, but you can actually pass in a second argument, which we're going to see inside the code, to pass a specific model that you want to use in the sentiment analysis category. And then once you have this pipe or the function to do this transformation or this inference, you can then call it with this, in this case, a text, which is going to tell you or label this text to see if it is a positive or a negative sentiment. Now, if you scroll down, you can see there is getting started guides and tutorials and even examples of using some of these models. One quick note is that not all of the models can be run using the Transformers JS library inside of a browser, because they have to run in a specific runtime to be able to run it inside of a browser. So you can see at the bottom of this page, they talk about all the different models that you can actually run using the Transformers JS. So definitely have a look at this. So let me take you back to the Hugging Face models. So let me just make this a bit smaller. On the left hand side, you can see the different filters available to you when searching for different models. For example, you can go based on a specific task or a library. So let's say we want to search for object detection. So we want to see all the models that do this, but we also want it to run on transformers.js library. So therefore, we can only filter based on the models that are available on this runtime. So you have the task here, which is divided to computer vision, natural language processing, audio, so text to text, image to text, text to image, and different things. But you can also narrow it down based on the library. Now we're going to use this ResNet 50 from Facebook to actually implement this object detection. Now let's go back to the docs and go to Transformers.js. Now on the left hand side, you can see there is getting started installation guide and the pipeline API. There's also some tutorials for implementing this Transformers in a vanilla JavaScript, React, or NextJS application. We're going to follow this NextJS app. And as I mentioned, you can use these Transformers to run these models in the browser, so client side or server side. For the purpose of this application, we're going to jump into the client-side inference or the client-side implementation of this transformer and build this together. So let me just go to the code and explain what we're doing from a high level as we're walking through this documentation. Now, the first step is to install NextJS. And once you've done that, you're going to also install, let me just make this a bit bigger. You're going to install the Transformers library. This is a Transformer.js. And once you're done that, you have to do some modification to your next config to change the way Webpack actually bundles your output for the browser by specifying this runtime and also the sharp package. So inside of our next config, what you need to do is export this Webpack property. Now, as I mentioned in the beginning of the video, we're going to deploy all of the ML related code into a web worker to ensure that it's not going to block the main thread while the model is loading. So all of these models are going to be loaded in the browser and then cached there from that point on, which is going to be easier to use them. But in the beginning, it takes a bit of a time for us to load this model and use it inside of the browser, but we don't want to block the main thread. So therefore, we're going to use a web worker, which is like a service worker that runs on a different thread. So the first step is to actually create this JS or TS file that we're going to hand off to the web worker. So inside of the lib, I have created this worker.ts. Let's walk over what exactly this file is doing. So we are creating this class, which is a singleton pattern to build our pipeline. So inside of here, I have defined a specific task. This is object detection. This is the ID of the type of models that you want to run. And the model is the specific model that we want to run. Now, to actually create an instance of our pipeline, we have this get instance static function. It is going to receive a progress callback, which we can pass into the pipeline function we create later on. We're going to see this in action. This is to kind of track the progress of loading the model inside the browser. And all we're doing here is to call this pipeline function, which we got out of the library. We're going to pass the specific task. This is similar to what we saw in the documentation. And as I mentioned, as the second property, you can pass in the specific model that you want to run and then an options object. Now, one of the things that you can pass to the options object is a progress callback or a function that you can pass in where it's going to get called when you're loading this specific model in the browser using the transformer. And finally, we're returning this instance. Now, to this web worker, we're also attaching an event listener to listen for events that is going to be sent to this web worker from the main thread. If you're not familiar with how the web worker works, it's basically a message system where you would hand off any data that you want to your web worker via these messages and via these event listeners that you can listen to in the main thread or in the web worker. We're going to have more videos on the channel about web workers and how they work. But for now, reference the MDN documentation. I'm going to link it in the description if you want to understand how they work. But basically what you need to do is create event listeners in your main thread and also inside of your web worker, just like how we're doing it here, and communicate between these two threads using this post messages function that allows you to send any data to that thread, perform tasks, and then return the result back to your main thread. So inside of this message or inside of this event listener, we're getting our pipeline instance by calling this get instance function on our pipeline, and we're calling it detector. And as you can see, I'm passing in a function here. This is the progress callback function that we're passing in, and this is going to receive the event or the progress when we're trying to load this model, and we're just sending whatever data that's passed to us from the transformer back to the main thread so we can use it there, set some states. We have a progress bar for how this load or progress is going. We're going to look at it in a second. But besides this, once we have the detector, we're going to pass whatever data that was passed to us when from the main thread to this web worker. In this case, we are passing in an image. This is the image that we want to actually analyze to detect objects on. So we call this detector function. We pass in the source, and then also some options here. Again, you need to reference the API for any specific model that you're using. For image or object detection, you can pass in %true. This is going to give you the bounding box of any object that's detected on the image. And percentage is to give that bounding box in percentage to the dimensions of the image. If you don't pass this, it's going to give you pixel points. Percentage, it makes it easier for us to draw that bounding box around the objects. And that's what's doing here. And once we have the result back from this inference, we're going to send a post or post a message or send the data back to the main thread. And again, we're inside of the worker right now. So we can pass in any data that we want to between the web worker and the main thread. Here I'm passing in an object that has a status of complete and a result, which is the result of this inference. So that's the first step. Don't worry if it doesn't make sense quite yet. When we implement the other side of it inside of our application or inside of our main thread, it might make more sense then. So the third step is designing the UI. So for this, we're using a client component, and this is our homepage. Let's go to our own app, and I'm going to explain what we're doing there. So inside of our app, inside of our page, this is where we're communicating with this worker. So let's see from a high level what's happening here. So we're creating this detector using the use callback function, and we're holding a reference to the worker that we just created. Now, how do we load this worker? Well, we're using use effect to load this worker and a use ref hook to hold a reference to this web worker. So we're creating a new instance of our worker. And when you're creating a new instance, you just have to give it the path of where the JS file or the module that you want to hand off to that thread. So for us is inside of our lib and inside of our worker.ts. So we're going to create a worker that just runs this script in a different thread, and we're holding a reference to it inside of our worker ref. So this is the ref that we're holding this on. So that's when the component mounts, and we have this detector function where if we have this worker, what we're going to do is we're going to call the post message on it, similar to the post message function that we had inside of the worker. We also have it inside of our main thread, and this is how we communicate between the two threads and pass jobs and receive results. So whenever we want to detect, we're just going to pass an object with the image property, which is going to kick off the inference that we set inside of our worker. So if I go back to that one more time, Let me close this off. So inside of our worker, once we receive this message, we receive this image property on the data because this is what we're passing into from this object. It will be available on the data property of this event. And we're passing it to this detector, which we got out of our pipeline, which kicks off that inference using the model to detect these objects. Now, once this process is done, this web worker, as I mentioned earlier, is going to also post the result back to our main thread. Now, inside of our main thread, when we created this web worker, we also created this onMessageReceived function or event listener, which we're going to attach to that web worker. And what we're doing here is we're receiving the result once it comes back, and we're getting different types of events coming back from our web worker. Now, initially, we're going to load this model using the transformer in the browser, and we want to set that progress. So if you can see here, we're initiating this request for the model, and then we have the progress status. And once this is ready, we're setting some local states here. As you can see here, we have the result. This is the result of the inference. The ready is when the model is ready. The progress is the progress of us actually loading the model. The status is whether or not we're ready, completed, and whatnot with our inference. So we're holding some local state, and we're updating this state depending on the messages and events that are sent to us from our web worker. This is how we are interpolating these two threads together to talk and to set some state inside of our main thread. And once we're completed with our inference, so once we have the result coming back, we have the status of complete because this is what we have said here. So once this detector actually goes ahead and processes this image, it sends a message with the status of complete and actually provides the result. And this is what we're listening to here. So if the status is complete, we want to get the result out of the data object on this event and set it to the result. And down here, finally, we're adding an event listener and passing this onMessageReceived callback function to this worker.current, which is the instance of the worker we created. We're returning also a cleanup function to remove this listener once we unmount this component. So let me close this off so we have a better understanding of what's going on again. We had this callback, which is a detector. This is how we send messages or send our image to the web worker to process. And inside of the use effect where we created this web worker, we also created this event listener. So we listen for messages that comes back, and we can set some local state so we can show what's happening to our users. Now, inside of this section, let's see the UI that we have. We have the titles. Let me just open up our application so we have a better understanding. So up top, we have the title. Down here, we have some progress bars that shows the user whether or not the model is ready. Now, to see this in action, because the model is right now cached, let me just go to the application and go to the cache storage. We should be able to see this models inside of our cache. So transformers cache. Let me just delete all of these transformers so we can load them again together. So if I go ahead and empty cache and hard reload, you can see initially we start without a model. Right now we don't have this model inside of the browser. Now, as soon as we start dragging and dropping a file here, so for example, I'm going to select this car. This progress bar, it actually tracks when we're loading this specific model into the browser using the transformer. And once we have it ready, this is what we're showing here. And inside of the use effect in these events that we're receiving from our web worker, this is how I'm setting the progress. So anytime that I'm receiving an event that has a status of progress, I'm getting this progress, which is a percentage, and setting it to a progress, which is a local state. And then I'm using a shadcn progress component, passing in a value. That's the progress bar that you saw in action. And once it's ready, we know we have it in the cache. The next time is not going to take that longer for us because we have the model there. It just says transformer or the model is ready, and we can just go ahead and drop our images here. Now down here, I have the drop zone component. This is using React drop zone component. We do have a video on the channel where I implement this from scratch. So if you want to learn more, I'm going to include a link in the description or in the card somewhere. So watch that video where we talk about React drop zone and how you can use the different callbacks to create this area which listens for drag and drop events for you to listen to files. You can also pass in different options. How many number of files do you want to accept? What type of files you want to accept? So from a high level, let me just explain what we're doing here. So we have this on drop callback that we're going to use inside of our use drop zone. So mainly the package is going to export this use drop zone hook, which is going to give you some functions for you to use to turn this div into what we need, a drag and drop zone. So you can specify different types. Here I only want to receive images, maximum size, number of files, and then this on drop, which is a callback that needs to be executed once a file is dropped here. Now inside of this on drop, I'm going to receive the accepted files and rejected files based on the constraints that I have specified here to the use drop zone. And if I have accepted files, what I'm going to do is going to create a preview URL using the create object URL so I can show it here inside of the browser. And I'm going to set some states. These are the states that are coming from the parent component to set the status and set the results. And then I'm going to read this file so that I can call my detector with this specific image. This detector is the same detector we defined here that receives this image and just passes this on or hands this off to our web worker to then run the model and detect the objects and give us the result back. So all of this inference is happening on this web worker. Again, it's not inside of the main thread. Now, a cleanup note here. We are revoking the object URLs that we create after we unmount this component to avoid memory leaks. And down here, this is mainly the div that you create out of this hook. You basically spread the get roots prop on this div, which turns it into a div that listens for drag and drop and gives you all the functionality inside of the preview. Once you do have a file, I'm using next image to just show the image. Again, let me select an image. So this is our image property here. Down here, for every bounding box that we're going to receive inside of the result. So let's go back. So once we receive the result here on our messages, so this is when we have the result, we set this local state, which is this state. We then passed it down to our drop zone component as a prop. And the reason why is that I wanted to show it on top of my image. For each of these bounding boxes that the model detected, I'm going to render a bounding box. Now let's go inside this bounding box. Now each of these detected objects are going to have a box, a label, and a score. Now your box is going to have the amount of pixels or percentage, depending on which option you passed in for your X and Y, from which we can calculate the left, top, and width and height of this bounding box to absolutely position it on top of our image container or on top of the image. I'm also rendering this span, which is this dog, which is the name or the label of this specific image, with a similar concept of calculating the left and top. And then also I'm generating a random color. So if there are multiple objects inside the image, each one of these bounding boxes are going to have a random color. And this is a function that's defined down here. We're basically creating a random hex color and setting it as the background color of our span and the border color of our bounding box. So this is how we are rendering the bounding box around each object that was detected from our model. Down here we have this button that just deletes the image, basically sets the state. Also the rejected files or the preview of the rejected files and a way to remove them all. And there you have it. We built an object detection feature using free open source AI models that are hosted on Hugging Face, which is a platform like GitHub, but for free open source large language models. And it also provides libraries like Hugging Face.js or Transformers.js that allows you to work with these models very easily. A cool pattern that we used here was using the transformers that allows us to run these models inside the browser. We could have easily done this server side as well, and maybe in future we would have more videos or more use cases with different models also running server side inside of our Next.js app. But it was cool to know that you could just run this, load these models inside the browser and run them inside the browser. Another cool pattern, in my opinion, was to hand off the loading and running these inferences to a web worker instead of blocking the main thread, which is a pattern that we need to use if we want to have interactive user interfaces implementing these AI models that can take time to load or can take time to process or generate these predictions and inferences. So a couple of different components and pieces that came together for us to build this application. If you have any suggestions for the type of models or AI features that you want me to build, let me know down in the comments. If you have questions about this one, like always, hit me up in the comments, and I'll see you in the next one. Bye-bye.